Hi everyone, so in this video I just want to show you how to develop this sort of disintegrating effect that you can see on the mesh as the character is running. So as they move they disintegrate out and you're left with just this kind of ghostly outline. Then when they stop moving they start to disintegrate back in again, I guess. So how this came about was we did a game jam recently where that was the basis of the game. So as you were moving you turned invisible so other players couldn't see you. Then if you ever stop moving, say to line up a shot or whatever to look around, you'll start to become visible again and therefore vulnerable. And this effect was what was developed for that, so I thought I'd turn it into a video to show you guys how to do it. Now we will do that from a brand new third-person template, so we'll do it all from scratch. But just to show you this would work with a character that's more complex than just the simple mannequin here, I have the Paragon Boris asset pack loaded. You know, the one you can get for free from the Epic Games Store. And I've done pretty much the same thing that we're going to do in this video, but to this character's materials. And you'll see it still works. As we're running, we start to fade out to this kind of white outline, which you can adjust if you think those lines are a bit too thick. And as I stop moving, we fade back in again to a fully textured model that looks how it normally does. Okay, so we're going to do that from scratch. So I'm just going to switch over now to a brand new third-person project. Alright, so here we have a brand new third-person template project. It's Unreal 427, although this should work in most versions. And as usual for this channel, I'll try and fully explain everything that we're doing rather than just say, do this, click here, type this in. Which will make the video longer than it strictly needs to be, but you'll get a full explanation of what everything does and how it all works. Now there's really two parts to this. There's what we're doing in the character's blueprint to detect when we're moving past a certain speed, and then to change some opacity variables. And then there's what's going on inside the material. Now we'll start with the blueprint side of things. We'll select the third-person character, and you can just in the world outliner click Edit Third-Person Blueprint to open the character's blueprint. Or if you prefer, you can always go through the content browser to find it at Content, Third-Person BP, Blueprints, Third-Person Character. Now this that you can see here on the event graph, if you go to the event graph tab if it's not already, is all the stuff that was there already by default, so the stuff that Epic Games have made as part of the template. Then we're going to add our own stuff to this. So to begin with, we want a function where we can check, are we moving slower than a certain speed? So what it is, by default, the character's maximum movement speed is 600. So we're going to say if we're moving slower than 300, half that speed, we should be fading in. If we're moving faster than 300, we should be fading out. Now to make that a little bit tidier, we'll create our own little sub-function here, a little function on the blueprint. So hit plus function and call that one fade in or out. Question mark, and call it fade in or out question mark. Now all this function needs to do is get our character movement component, which is already part of the blueprint, so you can just left click and drag that into the function. Off the character movement component, we can do a get velocity. Now there are other ways to access the player's speed, but I'm going to do it through the velocity on the character movement component. The other ways to do it, like if you're detecting just your ground speed, might not work if you're not moving across the ground but sort of just falling, whereas velocity should work all the time. So velocity will give us the direction we're moving and how fast. All we care about is how fast, so we're going to take the velocity vector and do a vector length on it. So what that is, the velocity vector itself will give you the actual XYZ direction that we're moving in. Velocity length will just be how fast are we moving without caring about what direction. And all we want to do is is that less than, so if we do float less than float, 300 in this case. Okay, and then our little function here can just return true or false, which we've already got from here. So this pin on the end here will give us true or false. Is our speed less than 300 basically? So we'll select our function. Then over in the details panel, add one output, which we will call something like, we'll call it fade in, because we'll be sending out a value of true if we're moving slower than 300, yeah? So fade in question mark. If this is false, we're not moving slower than 300, then we'll be returning a fade in value of false. Okay, and we can interpret that as meaning we want to fade out. Now we want to make this into a pure function, but just in case you don't know what pure functions are, let me go back to the event graph, hit compile, and this is something we want to do every frame, so let's get hold of event tick. There it is. So yeah, anyway, pure functions. At the moment, if I drag and drop fade in or out on, it comes in as a normal blueprint function like this that you would have to run the execution line through like that, which is not a problem. But to make things a bit tidier, we can select our fade in or out function and just tick this pure box in its details panel. Hit compile. I don't know whether you have to hit compile in between. I always do, just out of force of habit. Now when you drag fade in or out on, it comes in as one of these little functions that you don't need to run the execution wire through. That's what a pure function is. You recommended to do that when your function isn't actually changing anything about the blueprint. So it's not changing any of its variables or components, which ours isn't. This is just checking some variable inside the character movement component, essentially, and asking, is it less than 300? But not actually changing anything about the blueprint, so therefore making a pure function is okay. If you make a pure function which does change variables in the blueprint, you might end up unexpectedly changing those variables when you don't mean to, because of the way pure functions run. Anyway, so what do we need next? We want another one function in here we're going to make called adjust opacity. So we're going to have, first of all, a variable called opacity, or opacity, however you want to say that, and it's going to be a float, and we're going to have that in the range from 0 to 1. In fact, if we press compile, we can give that a default value of 1. So 1 is going to represent fully visible, 0 would be completely invisible, except for that kind of outline, 0.5 would be halfway through the fade effect, and so on. We'll also want another variable called fade time. Now it's up to you what you set this to. I'm going to hit compile and give it a fade time, default value of 5. So what that means is it will take 5 seconds to go from fully visible to fully faded out, and then 5 seconds to go from fully faded out to fully visible again. There are other things you can do to control how this effect works beyond just how long it takes, but we'll start here. Okay. So how is this next function going to work? So we're going to need new function again, and we'll call this one adjust opacity. And this is going to need to take a couple of inputs. First of all, the delta time. So on the event graph, the tick event gives you this delta seconds output. If you don't know what that is, that tells you in seconds how long has gone by since the last frame. And you need to use that whenever you're doing something that you're going to do every frame. So because we're going to adjust our opacity every frame, potentially, we need to take into account how much time has gone by since the last frame. Otherwise, it will work differently on, for machines with different frame rates, which is not what we want. Anyway, in the adjust opacity event, select the function there, and we'll add an input. We'll call it delta seconds, because that's what Unreal calls it. So how long has gone by since the last frame? That is a float. And we also want another input, which we will call increase, question mark. So that will be true if we want this function to increase our opacity, so it become more visible, and false if we want it to decrease the opacity. Now what do we want to do? This function doesn't need to return anything, it just needs to do some calculations. What it wants to do first of all is get our opacity, put that there, and it's going to add something onto it. So I'll just do a float plus float. Now the question here is, what is it going to add onto it? Because if we want to reduce the opacity, we're basically adding on a negative number, right? And if we're increasing the opacity, we can just add on a positive number. And where does this fade time come into it? Well, okay. If we wanted to increase our opacity, we could just take get our fade time here, do delta seconds divided by, so float divided by float, fade time, and then just plug the result of that into here. So why does the math check out here? Well, if you just plugged delta seconds straight in to there, because of the way Unreal Engine works, it would take exactly 1 second for opacity to go from 0 to 1, no matter what the frame rate of your PC is. So by dividing our delta seconds value by, 5, we're essentially making the effect 5 times slower, so it will take 5 seconds to go from 0 to 1 in the opacity variable, or the other way around. Okay, but that's only half the problem, isn't it? Because if we wanted to decrease the opacity, we would have to have a negative number here. So what are we going to do? So we will change our division. So we've got Alt and click on that wire to break it, so that this division is plugged into something called a select float. Right, so it's going to divide delta seconds by either A or B, depending on what we put into this pin here, pick A. So if pick A is true, it will divide by whatever A is. If pick A is false, it will divide by whatever B is. Now we can just plug our fade time straight into A like that. And then if for B, we want the negative of fade time. So we can do a fade time multiplied by -1. So I can do float multiplied by float, multiply that by -1, and plug that into B. And then how does it know whether to pick A or B? Well, that depends on what this increase pin is doing. See, so if we've said, yes, we want to increase our fade, we're going to end up dividing delta seconds by fade time, and we'll get a positive number out of that division. If increase is false, we will end up dividing delta seconds by fade time, times -1, and so we'll get a negative number coming out of here. So we'll add on a negative number to our opacity, which will actually decrease opacity. Now we want to make sure that opacity does stay in the range 0 to 1. So once we've added something onto it, we want to do a clamp float. Clamp float will push in some float number, give it a min and max, 0 and 1 of the defaults, and we'll leave them like that, that's fine. If the value that comes in is between 0 and 1, it passes through unchanged, inclusive of 0 and 1. If it's less than 0, it will be bumped up to 0. If it's greater than 1, it will pull back down to 1. So this will make sure that we never let opacity go outside of the range 0 to 1. Once we've done that, we can just drag opacity in again as a set opacity. The result of the clamp goes in there. Function goes into there, and I think we're pretty much done in here. There's nothing else this needs to do. Okay, compile and save that, go to the event graph, and then we can just drag adjust opacity on like that. Wire that up to tick like so. Our previous function, which tells true or false, are we trying to fade in or not, goes into this increase pin, and delta seconds goes into there. And that's basically all that needs to do. The next thing then is just to tell our mesh, the character mesh that we've got here and the components that was there already, part of the template, drag that in. Then off of the mesh, we've got something called a set scalar parameter value in materials. So what that's saying is, and you'll see this in a second when we go and do a really simple material just to test this, materials can have parameters inside them. Those parameters can have names, so we'll call our parameter something like opacity param. The reason I'm calling it opacity param and not just opacity is because there's already a channel inside the material called opacity, and I don't want the potential confusion there. Then what do we want to change that parameter to be? Well, we'll change it to be whatever the current value of our opacity variable in this blueprint is. Now, of course, at the moment, the 3D mesh as it is done in the third-person template doesn't have a material with this parameter in. So if you were to just play the game and run around now, nothing would appear to be happening. So just to check that we've done the blueprint side of this correctly, we're going to make a very simple material with a parameter called opacity just to check that this works at all. Okay, and then I suppose in the next part of this video, we'll change that material to do the effect that we actually want. Okay, but that's the blueprint side of things done. All right, back in the content browser, right click somewhere, make a new material. I'm going to call that m_player. And like I said, we'll start off dead simple with this. We will get a constant 3 vector, which you can get from here, the palette on the right hand side, drag in constant 3 vector, or you can hold 3 on the keyboard and click if you prefer keyboard shortcuts. Plug that into our base color, and we'll just make that into a red color. And this. Now, just to test that our opacity parameter is working, we will get a constant. Shortcut for that is 1 and click, or you can just drag it in from the palette. Set that to a value of 1 and just plug this into the opacity channel. Now, that's not going to give us the effect that we actually want, but it will let us test things out. We want to right click on that constant, go convert to parameter, and what did I call it in Blueprint? Opacity param, was it? Yeah, so what you're basically saying to Blueprint with that is, let me just rearrange the screen so you can see both of them. Go into the mesh, in its materials, find any parameters called opacity param, which is what this one is, and set their value to whatever this opacity variable is. The one we're raising and lowering using that function that we made. So that's how Blueprint can talk to materials. Now the reason why this won't work just yet is because we need to select the main material node or click in the background, and under blend mode change it to be a translucent material. Now, like I say, this is not the final effect that we want. It will look a bit bad, but it will at least allow us to check that we've done the right thing in Blueprint. Okay. Speaking of which, go back to Blueprint, select the mesh component, then in its details panel, change the two materials it uses to be the material you just made. So m_player in my case. Oh, and before I forget to mention it, if you didn't click the apply button inside the material, do that now, otherwise this won't work. Right, see, so as we play that and start running, we do start to fade out. So what we did in Blueprint is working correctly. If we're moving faster than 300, that opacity value is falling towards 0. Then when we stop moving, it will start to rise back towards 1 again. Then on any given frame, whatever its current value is, it's being shoved down the material here, and that's why this works. But of course that effect isn't what we want. The material doesn't look very good. So let's change this to something that actually looks a lot better. Right. We'll keep the red color wired into base color. We'll keep the opacity parameter here. We'll just break the wire here of this opacity one by holding Alt and clicking on the wire. And we need to change the material to be not blend mode translucent over here, but blend mode masked. So what the difference is, a translucent material can have bits that are kind of partially see-through, like how the mesh was just when we were running, it was partially see-through. Whereas a masked material can't do that. You can have parts of the mesh that are completely see-through, parts of the mesh that are completely visible, opaque, but you can't have any parts of it that are like half and half. But that's fine. For the effect that we're doing here, we don't need it to be. Now, to show you how this effect is going to work, we need to talk about what purlin noise is, if you don't know. So first of all, let's get a texture sample in here. So right-click, look for texture sample. Then if you've got the starter content loaded, you should be able to, on the right-hand side here, say which, select the texture sample node and then tell it to use something called purlin noise. So P-E-R-L-I-N, just search for that. If you don't have the starter content loaded, don't worry, because you can add it by going content browser, add/import, add feature or content pack, content packs, and then just choose starter content and add to project. Okay. Anyway, purlin noise. So what this is, you don't need to do this, but I'll just bring it up on the screen for you to see. Is this kind of black and white noise texture which are procedurally generated, and purlin noise is used to simulate clouds, and it can be used for like smoke and various effects like that. I'm sure looking at it you can kind of see why. And we can use this to help drive our opacity, but why though? Why would that work? Well, first of all, let me just change it so that the purlin noise is textured onto the model as its base color, just so you can see what that looks like. Hit apply. Let's go back to the level. See, so now if we put the purlin noise on as the base color, it would look like this. So you've got like some areas are very dark, some areas are lighter. Okay, so what? That doesn't really help us. But what would happen if we plugged it into the opacity mask? In fact, if we get just the red channel and plug that into the opacity mask. So for a grayscale texture like this, the red, green, and blue channels will all essentially contain the exact same data. So this would work if we did RG or B. Hit apply. So what's happened here is, all of a sudden, areas of that purlin noise texture that were very dark have become completely see-through. And areas that were lighter than that are not see-through. Okay, and our effect is going to depend on really changing where the threshold is for that. Like, how dark does that map need to be before it's considered see-through? And we'll gradually fade it from 0, so as in everything is fully visible, up to 1, everything is fully see-through. Or the other way, I might have got those numbers the wrong way around just now when I said it. Right? But that's like the crux of how this works. But how are we going to do that? Okay, well, back in the material, we will go Alt-click to break that link there. Alt-click to bring that link there, I guess. And then we're going to need to do something called an if statement. So you want to right-click and say if. So the if statement is going to output different values depending on whether some condition is true or false. Okay. So what we want to do here is take our opacity parameter and plug that into A on the if. Take the red channel from the texture, the purlin noise texture, and plug that into B. Then what we want to do here is look at these three little logics down here. if A is greater than B, so if the number stored in our opacity parameter is greater than the numbers coming from whichever pixel on this texture, output some number. In that case, we want to output 0, so we'll right-click, search for constant, get a 0, and just plug that into A greater than B, and for that matter, A equals B as well. So anywhere that our number here is higher than, I may have this the wrong way around, but we'll sort it out in a second, is higher than numbers coming off the texture, output 0, then get another constant, plug that into A is less than B, and change the value of that constant to be 1. Okay, now what you've got to remember is the value of that opacity parameter is going up and down as we move, right? Because that's what the blueprint portion of what we just did is doing. So which parts of this texture are higher or lower than this opacity parameter is going to change over time. So let's plug the results of that if down the opacity mask and just see if we've got that right. I may need to change a few things. I may need to start off, put these two the other way. In fact, I think I've got my 1s and my 0s the wrong way around here. We'll soon see, because we'll press play. Yeah, and yeah, I've got it the wrong way around. So we're becoming visible as we move, and then when I stop, we go invisible again. And also, I haven't plugged the red back into the base color. Okay, so two things. Plug the red back into base color. Then here, we change that 0 for a 1. And that 1 for a 0. Yeah, I thought something felt a bit off. That. Right, yeah, so where this parameter is higher than the values on the texture, we are fully visible. And where it isn't, we are see-through. All right, let's try that again, shall we? Hit apply, back to the map, hit play. So we've got a nice red on there. Then as I run, the threshold at which we consider to be invisible goes down. Then when we stop, the threshold at which we consider to be invisible starts rising again, basically, until the entire mesh is visible. Okay, so that's the main part of that. But when I showed you this at the beginning of the video, it did look a little bit better, and the reason is we had some kind of glow effect going on. So parts that were just about to become visible or just becoming visible had a strong glow to them, so it looked like the mesh was kind of burning in and out of existence, which is easy enough to do. It's basically pretty much the same technique we've just done. Right, so what we want to do here, we could start to tidy up our material a bit. I don't think there's anything else I need to do with this section. This is basically done. Move this over here. We need to reuse the texture and the opacity thing, so let's bring those over here. And we need another if statement. It's going to be set up slightly differently, and this is going to control the emissive color channel, so what parts of the model glow, if any. Right, so right click and get another if. Then what we want to plug into the A is the value of the opacity parameter minus, so just do a subtract, the information coming from the texture. Okay, so that will give you the difference between these numbers. So let's say the opacity parameter is 0.4 and the information on some pixel is 0.3. You're going to do 0.4 minus 0.3, so you're going to end up with 0.1. So the difference between the two. Now if A and B were the other way around, opacity parameter was 0.3 and the texture value was 0.4, you're going to end up with a minus number, minus 0.1, which is not what we want. So what we'll do is run the results of the subtract through an ABS, or absolute. So that will give us the absolute value of the number and just ignore the minus sign if there is one. That's going to be A. So what we've basically got here is, what is the difference in value between this parameter and each of the pixels on this texture? Now if that is less than some threshold value, which we define with another constant, come on, Unreal, constant. Now it's up to you what you put here. I'm going to go with 0.05. 0.05. Right, so we're asking, is the difference between our parameter and the texture less than this number or not, basically? If it is, then you're right on the bits of the model which are just becoming visible, okay? And so for them, we can say, well, you need to, glow really brightly. So we'll get a constant. I'm just going to hold 1 and click to make a constant. Plug that into the A is less than B. And we'll give that a nice high number like 50, so they'll glow quite brightly, these parts of the model. And then for these other two, let's get another constant, and then that 50 hasn't, 50, enter. Then get another constant, hold 1 and click, leave that on 0, and plug that into the other two pins. A is greater than B, and A is equal to B. So any parts of the model who are not basically about to become visible, just becoming visible, will not glow. Then what you can do is multiply that by our color. So we'll get right click and get a multiply. Take the value of this color. Take the value coming out of this if. Plug that into the emissive color channel, and then we should have that edge glow effect going on. Well, not edge glow, but the parts that are becoming visible are glowing. You'll see what I mean. Right, so as we run, see, so where the mesh is just turning invisible, it's got more of a bright glow to it. And if I stop, it has a bright glow just where it's becoming visible. Now, if you change the number in that, because this is quite configurable, so if we change this 0.05 to be something like 0.2, and then go apply, much more of the model will be glowing. In fact, you might have a slight bug where, yeah, bits of it are glowing start with, so you'd have to sort that out. But see what I mean? Like, so you have to be careful with that value. And then when we stop, yeah, see, much more of the model glows. Then we'd have to do something to stop it from glowing at the end. I'm going to put mine back on 0.05 because that worked quite well. The other thing we could change here, which I didn't mention, is the tiling on this Perlin noise texture. So here's the thing. If we tiled this texture more and more times across the model's opacity channel, you're essentially shrinking the size of these little blotches. The effect of that will be the model will seem to appear in like much smaller pieces. In fact, I'll just show you. So if we go back to the texture, right click and look for a texture sample. No, texture coordinate, sorry. Texture coordinate. And plug that into the UV's input on the Perlin noise texture. What we could do there is, with the texture coordinate selected, change U and V tiling to some high number, like say 50 and 50. Then go apply. Now what that will do, you'll see it will fundamentally change how this effect looks. So as I start running now, see how the model seems to fade out into like tiny little patches, and then when I stop, it takes a bit longer to kick in as well. So fades out, stop, fades in. So you may prefer it that way. You can just leave yours like that if you want. If we go the other way with this, so we take texture coordinate and change it to like 0.1, 0.1 for U tiling and V tiling, then hit apply. You'll find that the model fades in and out in much bigger patches. See? Then when we stop, actually works quite nice. I think having value of 0.1 for that, and what did I leave on 0.05 for the other important value, actually gives you quite a nice effect. So I'm going to leave mine like that. It looks good. That's what I had in the Boris the Paragon character as well that I showed you at the start of this video. Okay, so that really doesn't leave too much to do. We've got most of this done, other than if you wanted to put some comments in here. But we'll tidy up this material and put comments in a bit. The last thing was, when we are invisible, we need to be able to see the character. Okay. Now for that, we're going to use something called the Fresnel function and linear interpolation, which I'll quickly show you what those are. If we take a linear interpolate node, now you can right click and search for linear interpolate, or the keyboard shortcut is hold L and click. We get three inputs, A, B, and alpha. Now into A and B, I'm going to put two colors, so hold 3 and click, and then click again, still with 3 held down to get two colors. We'll go with a black on top and a white underneath. And plug those into the A and B inputs. So what comes out of here? Well, if we plug that into the base color channel, let's just have a look at just about previous fit. It's kind of grey. Why is it a kind of grey? Well, it's an equal 50-50 mix of its two inputs. So input A is black, input B is white. So you mix them together 50-50, you get this grey. Now the alpha input here, which we can change on the details panel, controls how that mixing occurs. So if alpha is 0, you get entirely input A, with no input B mixed in. If alpha is 1, you're getting entirely input B with no A mixed in, then 0.5 was half and half, and so on. And now what we want to do is something quite clever with our alpha. We can use something called a Fresnel function. So Fresnel, F-R-E-S-N-E-L, this one here, utility Fresnel. Plug that into the alpha, and that will change the value of alpha depending on the angle you're looking at the model from. So see here, and it might be easier to see this if I change the whites to be another colour, like, I don't know, red. If you're looking directly at the model, like here, where the mouse is now, it looks black, and then where you're looking right at the very edges of the model, it appears red, and that will be true no matter how you orient the model. Its outside edges are always going to seem to have like a red glow to them, right? We put that back to being white. We can use this to help with our opacity. Okay, because if we say, well, use information coming from this to add on to the opacity mask, which we're calculating from the Perlin noise texture, we can make it so that the outside edges of the model, or the edges of the model as seen from the camera's perspective, still have some visibility to them. Okay, that's pretty much all we need to do for that. We just want to, oh yeah, we'll make it fade in and out properly in a second, but for now we'll just put a multiply in. So hold M, click for multiply, output of the lerp into that. We'll plug that down we'll plug the red back into the base color channel first of all. Now you might think multiply by 1 is completely pointless, it won't change anything, and you are right, but we're going to do something with this input B in a second. For now though, what we want to do is get an add. You can right click and search for add, or just hold A and click for add. Take the result of that multiply, take what we were doing down here with that first if statement, the one that we plugged down the opacity mask channel, put that into the add, and then put the results of the add down the opacity mask. Okay, what that should do, we may need to add on to we might need to add on to this other multiply for the emissive if as well. In fact, yeah, let's do that. So if I get another add, so hold A and click, we're going to add the results of that lerp multiply, if you know what I mean, the one we just added, to the multiply that's doing our emissive colour, and plug that in as well. We'll delete that if it turns out to be a terrible idea. Oh yeah, and we may need to mess around with this Fresnel function a bit. So at the moment, if you select the Fresnel function, it's got an exponent of 5. We may come back and change that. But for now, what is our material doing? Well, you see the model has now got this permanent kind of white tinge to it. We don't want it to actually be there all the time. We'll deal with that in a second. But as we run, that is still staying visible around its edges as viewed from the camera's point of view. Now that does look a bit too not present in my opinion. You might like it, in which case don't do this next step, where I'm going to get the Fresnel function and change its exponent to 3. Okay. What that will do is make it so that that white glow is a bit more defined, like a bit more visible. Just show you what I mean. So hit apply, start running. We've got a slightly more solid white outline there, right? But it still gets the effect across, player's invisible. So last few things then, tidying up. We don't want that white outline to be there all the time. Like, it's still there now, and it's giving the model an odd kind of white sheen to it, which we don't want to be there. So back in the material, this second multiply that we had, this one here, the multiply after this linear interpolate between black and white, instead of just multiplying by 1, we want to multiply by the inverse of what our opacity is. So as the opacity parameter goes up from 0 to 1, we want the value we're multiplying by to come down from 0 to 1, and vice versa. So what we can do there is just take our opacity parameter and run it through what's called a 1 minus, and then plug that into the multiply, so basically inverting it. We've got a number in the range 0 to 1, run it through a 1 minus, we subtract that value from 1, so you get the opposite. So opacity rises from 0 to 1, the value coming out of here will fall, right, from, go in the opposite direction. So what that means is, by default, everything looks normal, that glow isn't there, but then as we start to fade out, that glow around the edges will start to appear. There you go. Then as I stop, now colour fades back in again, and that glow disappears. Right, so that's how you do that. Just wanted to make it, well, I say quick video, what are we on, 30 odd minutes? That's not too bad. Just explaining how to do that effect. As I did say earlier, it will work with other characters. Let me just show you if I've still got that project open. The one with Boris, hold on. this one. So Boris was a slightly more complicated case because this mesh actually has multiple materials on it, so you have to go and add our effect to multiple materials. But all that involves is... so first of all, this is the Boris blueprint. No, it's not. Okay, where's the Boris blueprint? That's the Boris blueprint. Yep, there he is. So on the event graph, I've done the exact same thing we did. I've called the parameter opacity effect rather than opacity param because I think in Boris's materials the name opacity param is already used. So opacity effect, just to keep it, we have to use a different name. Other than that, these functions are the same, so the blueprint stuff is identical. Then here's where it gets a little bit more complicated. The materials on Boris, first of all, they use a material instancing system, which I haven't talked about in this video and aren't going to. Already have all of this set up. This has already been done by Epic, right, as Boris's material. Then right before the end, I've spliced in this new material function which I made. So this wasn't there initially, it just went like that, right? So I spliced in this new material function, which takes in our opacity effect parameter. And if you look, it just says, look, get whatever the material's doing now. So it's base color, metallic, specular, roughness, all that stuff, and just pass it through completely unchanged, except for the emissive color and opacity mask channels where you do this. And that's all the stuff we've just done. I've just put some comments on. So there's the if statement for opacity, the opacity mask. There's the one for blowing around with the edges of the fade. There's the one for the edge glow while we're invisible. It's all the same stuff we've just done. I've just put some comments on and just basically spliced it into the existing materials. So you can make a material function and do that if you need it to work with an existing asset. But yeah, that's all I wanted to go through today. So thanks for watching. I know there hasn't been much going on in the channel for about 2 years, but I will try and get on top of releasing more regular tutorials if you guys want. Let me know what you'd like to see. And yeah, I'll see you guys later. Bye.